Okay, integration by partial fractions. So in 20-1, we did adding and subtracting rational expressions, right? So you would get something like this. 5 over x minus, do you want to teach this? Really? Want to talk that much? Come on up. Here, you can do this. This is an example. This is like 20-1 stuff. So. Yeah. You in here should be able to do this, right? So how do we do this?
Easy.
Easy. What do? You need a common denominator. What's common denominator?
X minus 2 times x plus 1.
Right. So what do we do with the 5?
Times it by x plus 1.
Times it by x plus 1. What sign do I write here?
Minus.
Minus. What do I do with the 1? Multiplied by x minus 2. Okay, what's that give us? 5x plus 5 minus x plus 2 over x squared minus x minus 2, which is what? So we've got 4x plus 7 minus 2. Okay, so here's the deal. If I said, what is the integral of 4x plus 7 over x squared minus x, make that look a little more x-y, minus 2 dx? And you would say, I don't know, like, how do you do that? But if we say, well, wait a second, isn't that just the integral of 5 over x minus 2 minus 1 over x plus 1 dx? I mean, those are the same thing, right? Well, we could do this integral, right? I mean, it's 5 ln x minus 2, absolute value of ln x minus 2, minus ln of x plus 1 plus c. So, what we want to do is work backwards from this. Right? Not to this, but basically go to this. So we have to learn how do we go from this and get it back to this. Okay? And that's what we're going to do. So we're going to look at how we can take an expression like this, go back to an expression like this, because that's easy to integrate, right? But it's that, ln that, ln that. Boom, done. So, here's what's happening. Let's see if we've got this by now. Given any rational function, p of x over q of x, right? Where p and q are polynomials. Given that, then f can be expressed as a sum of simpler fractions. And there's various theorems that go along with this that show that you can do that. Provided that the degree of p is less than the degree of q. So we're going to have to look at, well, what do we do if it isn't? And that would be called a proper rational function. So we'll have to learn, what do we do if it's not proper or improper? It's called a partial, it's called a proper rational function. So let's digress and head back to junior high or elementary school, back when for example, right? 3/4 is what we would call a proper fraction, right? And 7/4 is what we would have called an improper fraction, right? So back then you'd go 7/4. Well, that's an improper fraction. So we would need to change the improper fraction into a proper fraction. And how do we do that? You divide, right? Yeah. 1 3/4. Idea you go. So 4 goes into 7 once. 1 times 4 is 4, gives you 3. Got a remainder of 3, right? So 7/4 is equal to 1 plus 3/4. And now you have a number and a proper fraction, right? So that's what we're going to have to do. So if the degree of P is greater than or equal to the degree of Q, then we have to divide. So that so we end up with f of x, which is equal to p of x over q of x. This is divided. Oh, it's a little. To give you s of x plus r of x over q of x. Right? We did 7/4 is equal to 1 plus 3/4. Right? 7/4 is equal to 1 plus some remainder. The remainder was 3 over the divisor, which is 4. Okay, and in this case, s and r are also polynomial functions. Well, let's say r and s. R and s are polynomial functions. Okay, so let's say we had. No, I'll let you here. Let me pause.
You know where my cat decided.
Okay, so let's say we have to work out this integral. X to the 4th over x minus 1. Then we have to recognize, okay, look, the degree of the Doppler effect. If Dr. Seuss did physics, you'd get red shift, blue shift, no, 1 shift, 2 shift, red shift, blue shift. Really good. Okay, so let's divide x minus 1 into x to the 4th. Now you can't just leave that. We're dividing in, then we also need, you need an x cubed, and you need an x squared, and you need an x, and maybe a constant, right? So we're dividing into that, right? We do long division, right? So x goes into x to the 4th, x cubed times, and x cubed times this gives you x to the 4th minus x cubed. And you're subtracting, so 0 minus negative x cubed is positive x cubed. And we can still divide, right? What? That's right. Come on. Did you never do division? No, I don't know. Go ahead, do the shortcut stuff. I'm doing long division here. I don't remember the shortcut stuff.
Not the synthetic division where you just
Yeah, you could do that if you like. Okay, x goes into x cubed, x squared times. You look in all the books, they all do long division. I don't know why. It's like they all forgot how to do synthetic division. And me included, right? So I'm just doing long division. So x squared times that, okay, and let's bring down plus 0x squared, right? All right, so we get x cubed minus x squared. 0 minus negative x squared is positive 1x squared. Bring down the x. X still goes into x squared, right? As long as this degree is less than this degree or equal, you can divide, right? All right, so what do we get? Plus x, which gives us x squared, that was an x, minus x, right, which gives us an x, because we're just basically continuing the same thing, and bring down the 0, and x goes into x, so plus 1, and that gives you x minus 1, which gives you a remainder of 1, right? Remainder. R for remainder. So, what do we write? So that's equal to the integral of, okay, this is your S of x, right? It's your, what do you call the thing after you divide the divisor, and it's like a quotient, right? I think, yeah, quotient. I don't even remember how to do synthetic division, so I don't remember the terminology first. So it's x cubed plus x squared plus x plus 1 plus 1 over x minus 1. Because that's the remainder is 1 over this. Dx. Now, it's the sum of integrals, right? Which we know is it's the integral of a sum, which is the sum of the individual integrals. So I could rewrite that, but I'm not going to. Or we could just take the individual integrals, right? So, what's the integral of this? And neat, huh? Okay, so what we've done is we split it out. Now we did that by doing a division, right? So if the denominator is a higher power, put your trust in a higher power than the numerator, then you have to divide it out to get a quotient plus a remainder, right? And the remainder, that's the guy that's going to end up as, hey, the natural log, right? Because it would be something over something. And this something has to be just a number, right? Which we then just put in front, right? If that was a 5, it'd be 5 long, right? Because it's just a constant that can be moved. Okay, so here, let's do another one. So what if? I'm going to change my notes slightly. What if? What if we got this? So you look and you say, well, the denominator is not of a higher power. I can't divide this. You can't divide an x squared into an x. That doesn't. So, and don't forget the dx. So, okay, we're going to factor this, which is what? Two x and a 1 and a 1. We got a plus and a minus to distribute, and the 1 minus should go with the 2, which is over here. Now, for your sake, check this. Because if you get this wrong, then everything else is wrong, right? So 2, oops. That's why you check this, right? 2x squared minus 2 plus 1 is minus 1 minus 1, right? You are not going to get the numbers wrong. You're all beyond the stage of getting the numbers wrong. You will get the signs wrong. You are not beyond the stage of getting the signs wrong, as many of you have done that. So if you foil it, check it, right? Because otherwise everything changes from this point on, right? If this is wrong, everything's wrong. Okay, so here's the deal. Yeah. Easily fixed. After he goes on about the copy, and then if you copy the question down wrong on the second line, it just all goes back. Okay, so here's the deal. Grad rehearsals until later. Here's the deal. We want to do this, right? So we're going to separate out from the question now. We're going to go do a little aside for a moment and say, I want to write this as a partial fraction. I don't really need those brackets, but I'm going to throw them in there. So I want to write this as something over 2x plus 1 plus something over x minus 1, right? So I know I can do that. How do we know? Because we just did the reverse of that, right? We took something of the form a over this, and we just, well, okay. So if I didn't know this, then I would say, well, what are you going to do? Well, you're going to take A and multiply it by, well, you're going to add these. So to add, we need a common denominator. What's the common denominator? 2x plus 1x minus 1, right? So what is the A going to be multiplied by? X minus 1. What's the B going to be multiplied by? 2x plus 1. And what's that equal to? Well, it's equal to 5x plus 1 over. So we need to solve for A and B. When we've done that, we're going to rewrite this. Or nobody say, hey, where's the dx gone? We're going to rewrite this as this with our values for A and B. And we're going to say, yeah, it's easy to do the integral of, right? Because they're just going to be numbers. Okay, so there's an easy way and an easier way. Easy way and the easier way. So we could say, all right, look, we know that 5x plus 1 has to equal A times x minus 1 plus B times 2x plus 1. For any value of x, this must be true, right? It is an identity. So we could multiply it out and get ax minus a plus 2bx plus b, and then solve a system of equations, right? So we can do a system of equations. But we have an alternate way that we can do this, right? A little bit easier than solving a system. And that is to say, you know, if I set x equal to 1, then this a is going to disappear. And this is just going to be a number, and b, and this will just be a number, right? If x is 1, this is 6, this is whatever, 3, and that's b, and that's 0, so then b will equal 2, right? If x is equal to 1, that's gone, b equals 2. Okay, so let's do this a little more formally as opposed to me waving my hands and saying, okay? So, set, no. I set x equal to 1 because I know that that's going to make this 0, which means I will not have an a. I will just have a b and numbers, which means that's quite easily to solve, right? Quite easily to solve. That makes sense. It's easily soluble. It will devise. Will devise in water. Okay? So, we set x equal to 1. We get left side is 6. This is gone, right? Because it's a times 0. And we get 3b. So what's b? B is equal to 2. Okay. Then what do we set x equal to? What's going to make b go away? Negative 1/2, right? Okay, so let's go over here. Set x equal to negative 1/2. That's not randomly chosen, right? So did you just pull a 1 out of the air? No. I said, hey, if x is 1, this goes away. If x is negative 1/2, this goes away. So what do I get? 5 times negative 1/2 plus 1 is equal to a times negative 1/2 minus 1 plus b. And I'm just going to write in a 0 there because that's what it's going to become, and I'm running out of room anyways. Okay, so that's gone. All right, what do we get? Negative 5/2 plus 2/2 is negative 3/2 is equal to a times negative 3/2. So a is equal to 1. Nice, huh? Now, you could have got the same answers by creating a system of equations, right? 2 equations, 2 unknown, and solving the system. Okay, and the way you would have done that, should you so desire, I would have done this. And then I would have gone, okay, hang on, we got a plus 2b, which is x. What's this? Minus a. And then b minus a, right? So I'd say, well, okay, the number in front of the x is a 5, so that this expression is equal to 5, and b minus a has to be equal to 1, right? So just set it up. So hey, they look the same, so that's a 5, that's a 1, solve that system. What you'll get b is 2, a is 1, right? b is 2, you get 4 plus 1 is 5, hey, that's a 5, and 2 minus 1 is 1, hey, that's a 1. Okay? So you can solve the system, but it's a little bit easier to do it this way, right? It requires a little, recognition that, I can make that a 0 if I do this. Okay, so where are we now? We are now at the form where we are going to write the integral of 5x plus 1 over 2x plus 1 x minus 1 dx is equal to the integral of 1 over 2x plus 1 dx plus the integral of 2 over x minus 1 dx. Okay, so all we've done is, right, the a was over 2x plus 1, and a is equal to 1. And the b is over x minus 1, and b is equal to 2. All right, well, it's pretty trivial now, right? Okay, so once we've got it written as a partial fraction, and it's just really just natural log of the denominator, right? With the numerator thrown in front, for good measure. Plus c.
Why don't you divide the first one by 2?
There's no 2, I can't. If it was 2x plus 2, I could write it as 1/2 of the ln of x plus 1. I can't factor anything out of this. I can factor a 2 out, right?
Yeah, no.
So that's 2 times
When
ln
you
of
take the
x.
derivative of that, that's your inside function.
What?
When you get the derivative.
Yes, and because of doing u substitution in our head,
You're so smart, Mr. Yanover.
we need a half. Thank you to Zach,
There you go.
who shall remain named in perpetuity. So right, yeah, because the derivative of ln 2x plus 1 is 1 over 2x plus 1 times 2. So we got that little half in front. If I just wrote down the stuff that was on here, I would get into a lot less trouble.
I was afraid of.
All right, fine. Then
I was like, wait, why is it? This one got you the same thing. Yeah, I was okay with it. I was like, why is it 1/2? So do I need
there. You should be even happier about that.
It's not wrong.
Yeah, no.
No, that doesn't make sense.
That's the same thing. It just has a common denominator of 2.
Why?
Well, okay, so, and the question is why, and that's a reasonable question. What if this is what appears in your multiple choice answer and this doesn't?
These tests take longer.
So you're sitting looking at this, and you're not finding it, but you do find this, you have to recognize these are the same. It's like this one, which Zach came up to me yesterday about.
This one's dirty.
What's this?
Long secant. That's so dirty.
So this says sometimes when you have a negative, then you do the ln of cos x to the -1, which is the secant. So sometimes when you have this, it may appear like this, right? You have this, you should change it to a plus because you can take the inverse of cos and get secant. Okay. Same deal, right? You're looking at a multiple choice test. You've got this written down. You don't see it in the answers, but you see this. You have to recognize it. Oh, right? This is, which is that. Right? And we know this because of Zach. Okay, sometimes a factor in the denominator occurs more than once. So if you think of let's just go back to a regular old fraction. If you think of 15 over 16, and you're going to split that up, right? Then the denominator (16) is equal to 2 times 2 times 2 times 2, right? So if you're going to split up 15 over 16, you may get some halves, right? There could be some halves, or quarters, or eighths, or sixteenths. Right? So you have to say, I might get a certain number of halves, and I might have a certain number of quarters, and a certain number of eighths, and a certain number of sixteenths in the original addition. Right? So in the original addition. Addition? Addition. Right. So if I had a half plus a quarter plus 1/8 plus 1/16, that would be equal to 8/16 plus 4/16 plus 2/16 plus 1/16, which is actually, hey, 15 over 16. Right? So this could have been the original addition you were given, a half plus a quarter plus an eighth plus a 16th, right? And that equals 15 over 16. Now, we're dealing with slightly more complicated expressions, but we have to account for every possibility. Okay, so we have to account. We might not have them all, but we need to be able to account for them all. Okay, so here's the big example. The last example, as it turns out. Okay, so if you have this expression, right, which we're first going to do as a partial fraction, and then we'll do its integral, right? But first we're just going to work it as a partial fraction. And the first section in the book on questions just says, write the expression in the form that you would use to solve the partial fraction, but don't actually solve it. Okay? So just remember for the first 8 or 9 of them, it just says, write the expression in the form that you would use to solve it, but don't actually find the values. Okay. So we need to account for a denominator of, well, there could be an x minus 3 in the denominator. There could be an x minus 2, and there could be an x minus 2 squared. Okay, so we have to count for that possibility, that that's how this thing is going to split out. So we're going to write this. X squared plus 1 over x minus 3 times x minus 2 quantity squared is a over, well, could have an x minus 3. You could just have a single x minus 2, and you could have an x minus 2 squared. Okay, so basically if you see a squared in the denominator, when you go to write the partial fraction, you have to say, oh, well, I could just have the thing to a power of 1, or I could have that thing that's being squared to a power of 2. Okay, that's how we have to write it out. Then what we're going to do is go through and multiply both sides by the LCD, right? X minus 3 times x minus 2 quantity squared. Make sure I've written this right. Yeah, it looks good. Okay, so x squared plus 1 is equal to a. What do we got to multiply the a by? Like it's got an x minus 3, so it needs to be multiplied by x minus 2 squared. What does the b get multiplied by? X minus 3 and x minus 2. What does the c get multiplied by? Just x minus 3, right? Okay, so we're multiplying by this expression, that takes out, here it takes out the x minus 3, you're left with x minus 2 squared. Here it takes out one of these guys, leaving one of them and this, so x minus 3, x minus 2. This takes out the squared, leaves the x minus 3. All right? So, let's pick a value for x, any value. Let's start with 2, right? If we choose x equal to 2, what's that going to do for us? It's going to wipe out a and b, right? So we're just going to end up with 5 is equal to negative c. Okay, so let's do that. So let x equal 2. So we get 2 squared plus 1 is equal to a, 2 minus 2 squared. Right? It's gone, that's just 0. Plus b times 2 minus 3 times 2 minus 2. Gone. Gone as in 0, right? Plus c. Okay, so a little bit of math. We get 5 is equal to negative c, which leads us to c is negative 5. All right, so now we know c is negative 5. What's the next thing we might want x to be? If we make x 3, what are we getting rid of? B and c, which means all we can solve for a, right? Like we will immediately be able to solve for a. So, where do we go? Let x equal 3. So 3 squared plus 1 is equal to a times 3 minus 2 squared plus b times 3 minus 3 times 3 minus 2 plus c times 3 minus 3. So those two terms become 0, right? So what do we got? This is, and this is a. So what's a? If 10 equals a, then a equals 10. Okay, now how do we figure out what b be? What b be? Okay, here's an easy way to figure out b. So, the squared terms, the terms that involve squares are a and b, right? You are going to end up, when you expand this, you're going to end up with ax squared, right? Plus other junk. Here you're going to end up with bx squared plus other junk. So what do we know about ax squared plus bx squared? Okay, so what? So here's the thinking, right? If I let, if I just do the ax squared plus bx squared, what's that got to be equal to? One x squared, right? Because over here we've got 1x squared is equal to, all right, this is ax squared minus 4xa minus 4a. We don't care about the rest of those, right? We just care about, you're going to get an x squared term, and it's going to be multiplied by a. You're going to get an x squared term here multiplied by b. So ax squared plus bx squared is equal to 1x squared. We know a. So 10x squared plus bx squared equals 1x squared. What's b? Negative 9. We got b. We got a. We got c. Yep.
You could just say that ax squared equals, or plus bx squared equals x squared.
Yeah.
That's because they will pull out.
So you're going to get this, if you expand this out, you're going to get ax squared minus 4ax minus 4a plus bx squared minus 5bx plus 6b plus cx minus 3c. So if you look at it, you say, well, look, these two guys, that's what's your x squared term, right? So a plus b has to be equal to 1. Okay? You could even write that down, really. You could just say a plus b has to equal to 1. I know a, so therefore I get b. Okay? you could also solve for a system of 3 equations and 3 unknowns.
So the rest of it be one then?
The rest.
The rest
Yeah,
of it.
yeah, everything else. So you should get 0x, right? So if we did this, what do we know? So here's what you would do with this, right? Where do I have room to write? So you would write this as a plus b x squared, right? Then what? So our x's are going to be minus 4a minus 5b. So let's go with, let's put the x afterwards. Plus c minus a minus bx. And then constant would be 6b minus 4a minus 3c. That should be 3c. There. So you can say, hey, okay, I know a plus b is 1. I know that c minus a minus b is 0, because there's no x term here. And I know that 6b minus 4a minus 3c is 1. You could solve that system, right? Why you'd want to, I don't know, but you could. Actually, your calculator can do it for you quite easily. And if you know how, feel free to use it. And if you don't, it's matrix stuff, actually. Yeah. Oh, besides, you don't have calculators, so sorry. If you're doing your homework and you want to solve that system, yeah. Sorry, no calculators. I misspoke. No, we're just going to do this now. If you had access to a calculator, it could solve the system for you. Okay, so that's our integral, right? So, first one easy. What do we get? 10 minus 9. Last one, not so easy. So you could do a couple of things. You could do u substitution. Or you could do u substitution in your head. My head's not working too great today, so let's actually write out the u substitution. So we come off to the side here. So let's just go minus, it's 5 times something, right? We're just going to pull the 5 out.
Why don't we just do like minus 10 natural log minus 2?
Okay, well, you could do that. What do you think it is?
Minus 10 natural log x minus 2.
All right, this is our working hypothesis. Now I'm going to do u substitution, and we'll see if it really is. So let's just work this out. 1 over x minus 2 quantity squared dx, right? Well, put the 5 in front. Okay, so what do we say? Let u equal x minus 2. What's du? dx. Okay, so what are we actually working out? It's 1 over u squared du, which is u to the negative 2 du, which is what? We could sort of forget about the c because we're going to throw it in there anyway. So what's that? Negative 1 over u. What's that? Negative 1 over x minus 2. So, sorry, not a 2 there. So maybe it's best not to do u substitution in your head.
Yeah, plus.
Ah, so it's minus a negative, which will be plus.
That's not long, is it?
What, where?
Just one of us.
Oh, right. Yeah, I just wrote what he said. Okay, plus 5 over. There we go. Yes. I shouldn't have told you, right? It's just the 5 is there, and then we got to work out what.
Alright, let's finish right here.